I'm Victoria Coles. I'm a physical oceanographer at Horn Point Laboratory, and I wanted to tell you about how I became an estuarine oceanographer. When I was trained, when I was a graduate student, I actually studied Antarctic bottom water, which is really, really cold water at the bottom of the ocean near Antarctica. And I studied how it had changed over time. And when I moved up to Horn Point, I actually continued to work on problems that were like a whole ocean basin or the global ocean. And one of the things that happens to you when you live on the Chesapeake Bay, especially if you live on the water and you see it every day, you see the changing of the seasons, you see the submerged aquatic vegetation come in and go out, and the geese come and the geese go, and the ospreys show up every year, and you just become fascinated with the magic of this estuary. And so I wondered what it was that I could bring to the estuary, and I realized that my experience with big models, with global scale models, was something that could be really useful here. And so that's how I started to work on the Maryland Commission on Climate Change using global climate models to understand what climate impacts might be facing Maryland. And and once I had completed that work, I, wanted to keep going. I wanted to understand more about not just what might happen in the future in the Chesapeake Bay, but what had happened in the past. And so we started to look at what climate change had happened over the past 100 years in Chesapeake Bay. And and we're so lucky because this area has so much data. There's just an amazing long climate records that you can look at. And we wanted to take a little bit of a different perspective on looking at that climate data. We wanted to understand not just how um, average temperatures had changed over Chesapeake Bay. We wanted to know really about the day-to-day temperature and precipitation. This is what an organism or a person or an oyster feels. So, the average temperature in the summer might have increased by 1 degree. But what does that really mean on a day-to-day basis? So we started to look at what they call extreme climate indices over the past 100 years in Chesapeake Bay. And I think I was surprised at how much things have changed in 100 years. So we started to see that precipitation is much more intense now than it used to be 100 years ago. And we saw that growing season lengths have increased. And we saw that the number of days that are really hot in the middle of the summer have increased. So it's not just that the actual hottest temperature hasn't changed very much, but it's more like the period of time that organisms are experiencing those hot temperatures have really increased over the past 100 years. And and so we wanted then to take that information and link it to the organisms that live in the bay or the people that live around the bay. So what we can find is that we can link that increase in summertime water temperatures, how long they're persisting as warm, to declines in submerged aquatic vegetation in bay grasses. And we can link changes in when the growing season starts to which larval fish are better suited. Some years when it starts late, some fish do better. Other years when it starts early, a different fish species seems to do better. And we could link changes in the wintertime temperatures to how long you had persistence of harmful pathogens in the water. So those climate patterns that we looked at were relevant to people. And that, is really satisfying. So I still like to work in the open ocean, and I still run computer models of the Atlantic, but it's really satisfying to me to do something that's useful for public health, for transportation, for understanding the ecosystem in the bay, and also that's linked to climate into the future. I have 3 kids, and I want to know what the bay and what their climate is going to be like in 50 years. So that's a pretty motivating reason to study climate in Chesapeake Bay.